All right. We hopefully should be live. Although it does not actually seem... Oh, no, I am. It looks like I am. Can someone in the chat confirm that they can hear me loud and clear? All right. Let me know if the audio is not loud enough and I can adjust it. That was an issue last time. Welcome to a Code Report live stream. We were supposed to do this last Friday, I believe, but then my co-host of one of my podcasts, ADSP, ended up joining the live stream, and then we basically talked about something. I mean, 10% of it was related to combinatory logic, but it was not at all what I had planned. So this is the stream that I had said we were... My voice is doubled. Give me a sec. Let me see if I can fix that. All right, does this fix it? I'm pretty sure it's not the echo of wisdom. Okay, yeah, sorry. I was recording audio from my desktop earlier, and that seemed to have messed it up. All right, we're going to get rid of these headphones now because I don't need them. One person said that it hadn't been fixed, but it looks like they just deleted their message, so hopefully this is fixed. Yeah, let me just know if there's any issues. We'll tackle them as they come up. But as I mentioned, this is going to be a live stream, hopefully under 3 hours, ideally 2, but my guess is this is going to take a little bit longer than that. And we are going to basically program some stuff in C++ that does some combinatory logic things, which I'll explain in a sec. So on the previous stream, I went through a bunch of links. I just put those in the description this time. So if you look at this video down in the description below, you can see a bunch of links to podcasts I do, etc. But in this one, I'm just going to hop straight into things. So we're at a website called combinatorylogic.com. If at any point I'm talking about something and it doesn't make sense, just ask a question in the chat. I'll do my best to monitor it as we're doing this live coding. But basically, this is a table that enumerates a bunch of combinators, their combinator bird names, and different quote-unquote spellings of those combinators. What is a combinator? It's basically just a way to compose functions. If we go over to my terminal and we start Haskell, they have a bunch of things built in, combinators built in. So id is a name of the I combinator in Haskell. So if you pass it anything, it basically just passes you back that thing. And so if you can pass it a function like plus, I guess you can't do that. Or so maybe if you go, does this work? It'll show you the type. Yeah, so you pass anything to the I combinator and it just returns you that thing. And if we go back to our combinator table, zoom in a tiny bit, you can see the I combinator here. Basically, this is what explains to you using this quote-unquote function abstraction how it works. Everything to the left of the dot is the quote-unquote terms of the lambda or terms of the combinator, and everything right of the dot is the composition pattern. So for I, it's extremely simple. You give it an A, which is just a generic name for anything, and it passes you back that A. Pretty straightforward. Another combinator, well-known combinator, is the K combinator. Its composition pattern is that it takes two things and only gives you back an A. So in Haskell, this is known as const. If you give it two numbers, it's going to throw away the second one and keep the first one. If you give it two functions, so this first function is plus, the second function, so this is a binary function that takes 2 arguments, and this is a unary function that takes 1 argument and adds 1 to it. If we evaluate this, the :t is basically going to give us back the signature of the function that it returns. So in this case, it is giving us back, that's actually kind of confusing. Why is that the case? Well, this does make sense to me. Const 1 to, well, what happens if we, let's actually figure this out. Const plus 1 plus. So if we go f of 1, it's going to be a problem. But if we go f of 1, 2, it should give us 3, right? So I don't actually understand. Oh, yeah, no. So this is the, I don't know, type class thing. So the signature of this, it's actually a bit confusing. This does, to me, look like the signature of a function that takes 2 arguments. Oh, no, wait. I'm just totally confusing myself. This is correct. This is the signature of the plus. So we're given this expression, and it's going to return us the plus, aka it takes 2 integers a, or 2 numerics a, and returns us back an a. And if we, actually, let me clear this a bit because it's at the bottom of the screen. If we do the same thing, but instead switch these, we're now going to get back the signature of a unary function. So that is I and K covered. And then you get into more complicated things like S. So S is a function that takes 3 different arguments, A, B, and C, and then the pattern of composition is this. And the way that I typically read these, if we zoom in, I like to think of anything at the beginning of a parenthesized expression, and implicitly AC, if we copy this and go to our Gaubolt, this is the equivalent of A, C, BC, I believe. So like anytime you have an, actually, I'm not sure if the parentheses there, but basically, like, this is a short form and it elides a bunch of the parentheses. And the point being here is that I like to think of A as a function that takes arguments, B as a function that takes arguments, and then C here as sort of the arguments to those functions. So here, A is a binary function. It takes the argument C and the evaluation of BC, and then C is an argument that you pass to B. Technically speaking, when I say argument, these can also be functions, so it gets a little bit confusing to talk about these things. But in most cases, when I use the S combinator, C here is a piece of data. So if we go back to Haskell, I don't actually think S is built in. We have to import control.monad. And so now we should have this thing. Oh, we do not. Do I need to put it in parentheses? Yeah, okay. So this is known as applicative in category theory, but it corresponds to when f is a function to the S combinator. So my favorite example of this is if you want to check if something is a palindrome, aka it's the same thing, then you can do this. Let is palindrome equal, our binary function is match, which actually, how do you spell that in, we actually have to build that first. So all equal takes 2 things, and we're going to go equals all, and we can actually use the B combinator. Let's import the B1 combinator first. Import data.composition. And so let's all equal, and this is going to be an logical and reduction after doing a zip with the equality comparison. Oh. Right, because here, this dot is the B1 combinator. We actually want, the dot is the B combinator. We want the B1 combinator because zip with equals is a binary function. So now we can build up our, let's build up, so actually let's just put it back on screen. And actually let's put a couple comments here first. So dot is the B combinator. Dot colon is the B1 combinator. So now we have all equals, and we can go let is palindrome equal to all equal as our binary function, s combinator reverse. So what this is doing is if we pass it a string that is a palindrome, it's going to check if all of the elements of that string are equal to each other with the reverse of itself. So if we do this, we can now go is palindrome, and if we go cat, it's going to give us false, but if we go taco cat, it's going to give us true. Question in the chat is the phi the same thing as the s prime? Yes. I actually used to refer to the phi combinator as the s prime combinator. S prime comes from David Turner's work in the 70s, I believe. He kind of renamed the phi combinator, but the original name of the s prime combinator is the phi combinator. Specifically like just phi, because there's also a phi 1 combinator. Anyways, so let's take a look. I've mentioned B, I've mentioned B1. Here I'm demonstrating S. So let's go back to our table and zoom out a bit. So S, as you can see, A is a binary function, C is our argument, and B is our unary function. So in our example that we just looked at, reverse is our unary function B. All equal is our binary function that takes two strings. And then this sort of angle star angle is the S combinator that forms this composition. So you pass S, A, and B, which are all equal and reverse, and then it forms you this pattern, so all you have to do is pass it a single string now. Andy asks, are there some books or tutorials introducing these combinators with more hand-holding? Yes, I will put some, let's just do it right now. YouTube, actually, I already have all these things linked. What am I talking about? If you go to links here, so there's a bunch of links to different combinator tables, a bunch of articles, but my recommendation is these two videos, A Flock of Functions. I think in total they're like an hour, one's an hour and one's 45 minutes or something like that. And it goes a lot slower than we're going to do. The reason I'm going through this quickly though is we're gonna program a whole translation thing that should make this very, very clear how this works. I'm just trying to give like a very, very brief introduction to what a combinator is, in my opinion. There's different definitions for it. Some people talk about sort of the relation to lambda calculus, et cetera, but like I just think of these as like ways to compose functions. Specifically, like, so I've mentioned the B and B1. These will be the last two I cover before we start programming some stuff. This is just the dot and dot colon. The dot colon comes from data composition. But if we go down to B, you can see that the pattern here is A, B, C. So A and B here are unary functions, and C is our argument. So it's basically just like you pass your argument to one function and then pass the result of that to another function. It's very, very common. You end up doing this stuff all the time. So if I have a list of numbers and I want to add 1 to those lists of numbers, you know, I should put the 1 in there. That's going to add 1 to it, and then I need to put this $sign so that I can start building some things up. And let's put this back at the top of the screen. But now I can just use the dot operator, and I can compose functions. So now I can reverse it. I can take the first two, and because each of these take two, reverse, map +1, these are all unary operations. All I need to do is put this B combinator in between everything, and then it's constantly going to work. And I can go. Is there a sum function in Haskell? There is. So I can just continue to build up this nice composition of unary functions, and we're good to go. And note that like there was an error up here originally because map doesn't expect a binary function. It expects a unary function that can be applied to each of the elements. And B1 is very similar to B, except that instead of B being a unary function that takes a single argument C, it takes two arguments C and D. So it basically applies a binary function first and then applies a unary function A. And this was demonstrated if we go back to our all equal definition. So basically zipwidth is a function. Let's just do something with zipwidth first. So zipwidth, and this is basically a shorthand for make pair. We can do 1, 2, 3, and then 4, 5, 6. And this is just going to create a list of two tuples or pairs that are joined together. So you can replace this with any binary operation. So in our case, we were checking, are these lists equal to each other? In this case, every single one is different. But we can do something like, adding them together. And the point being is that when you partially apply a binary operation with zip width, you're going to end up with a binary function. And therefore, you need the B1 combinator, not the B combinator, because you want to apply this to 2 arguments first and then pass it to a unary function. And here is just the equivalent of basically a fold L, where you are checking, is everything in your list equal to true or something like that. Most recent comment in the chat says that the equal, less than can work as the S combinator, but the binary function has its arguments flipped. Interesting. Good to know. So yeah, multiple ways of spelling these things. And Casper, if I'm pronouncing that correct, says that map accepts just plus, but the result would be a list of unary functions, which isn't an instance of show. Interesting. Yeah, that Haskell is a pretty powerful language and can do some stuff. I have not actually gotten to the point where Casper, thanks for the pronunciation check, where you are building up lists of functions and then applying those to things. But I have seen it done in tutorials. Anyways, enough of sort of introducing. That was like a 10 or 15 minute summary. Let's sort of walk through what we're going to do in the next couple hours here. So if we go to here, our first example is, so basically what we're going to do is we're going to write a program to translate this column into our function abstraction form. And the ultimate goal is that we're going to generate a bunch of random compositions of S, B's, K's, I's, etc., and then translate them down into the function abstraction, put those in a map or a hash map that's indexed by this string, and the goal being, let's find a bunch of different spellings for these combinators. So like, for instance, the C combinator, the definition that this CR, so CR, actually, I guess I didn't mention this, stands for Chris Rathman, who has this site that for a long time was like my go-to when I was looking up these patterns. And he has definitions of these. He sort of has definitions where everything is in terms of S and K. And then he has a bunch of other definitions that are, I'm not sure what it's based on. Maybe it was taken from a book or something. But the point is that like, I think things like this, where you have B, paren, triple B, another paren B, triple B, like this is more, there are definitely simpler definitions of these combinators in terms of other combinators. And my goal is that on my website, I have like a list that is not populated here. And I want to populate this with like what I consider the simplest or most understandable version of sort of these spellings, combinator spellings. But first, let's see how you go from here to here. So if we take the definition of I to be SKK, how do you get from SKK to lambda A dot A? Yeah, I initially didn't get why S is equal to, so we have and that's what we're going to do right now. So we've got, this is the function abstraction. We'll just call that sort of FA for short. And then we've got this, what we'll call, for lack of a better name, combinator spelling. And it's SKK. So how do we get from one to the other? Let's build this up a little bit more. So basically, I just like played around with this until I figured it out. I actually did this like a year ago, so I might not get this right on the first time, but bear with me. So there's basically just a series of steps. And the first step is to look at the first combinator in our string of combinators, S, and then what we're going to call this, we're going to map sort of ABCs to SKI, BW, like whatever the spelling of this is, we just map. So we ignore the first one, and we're going to be applying the S pattern, and then we are going to basically name the KA, the second KB, and because S requires more than A and B, it requires ABC, we're going to basically put a C here, and then whenever we run out of space, so this is kind of like, X, Y, Z, asterisk, so I should zoom out a tiny bit. We're going to need to do some stuff if we run out of space, but this is our first step, is just to look at the remainder of our string after our first combinator, and then do this mapping. And actually, let's call this step 1. Second step is to, and we'll call this 2a, look up our pattern. In this case, it's S that we want. So, you know, if you're not familiar, you can come back here and look, but basically you just take this, you have to go look this up. And this is our pattern. And so that's all it is. We go and get this pattern, and we now need to sort of reformat this to make it readable. That's our second step. And our third step, which we're going to call 2b, is to substitute. Substitute. And it's actually funny. I mean, we can Google this. There's a paper called Logic of Substitution and Analysis. Actually, is this the best way to look this up? Analysis. An analysis of logical substitution. So this was Haskell Curry's first paper before he published his dissertation in 1931. And his first paper that he published on combinatory logic before he called it combinatory logic was this paper, an analysis of logical substitution. And I think he came up with the term combinatory logic in his dissertation, but like before it was called that, he just referred to this as logical substitution. So just anyways, it's a cool note because we are going to be doing substitution here, which is really just what we're doing at the end of the day. So we've got A, B, C. So A and B are K, and C is X. So hopefully this works. I hopefully don't mess this up. And I guess we don't even really need the first part. So our pattern is AC. So A is K, C is X, B is K, and C is X. So we're done. You're lost now. Where did I lose you? First step is mapping A, B's, and C's. Second step, looking up our pattern, which for S, because that's what we're the pattern we're looking up now. And then you basically, like our mapping here is K is A, K is B, and X is C. And then you just do a substitution. So this is K, this is X, this is K, and this is X. And there's a third step that we need to do called 2C, which is remove parens. Here we don't have any parens to remove those, so we're good to go. We just have exactly what we had before. And then you basically just repeat this. So maybe if you're lost, it'll make sense on the second iteration. We're going to do this with two different combinators before we start programming. But so now we started with SKK, and now we have KX parentheses, KX parentheses. And we're just going to do exactly what we did again. So step one is map A, B's, and C's. And the way we're going to do this is by going A and B. So our A is X, and our B is in parentheses KX. Hopefully that's pretty simple. Now we go back to step 2A, which is look up our pattern. Our pattern in this case, because we're looking at the first character of our string, is K. Like I said, you can go to the table if you need it. I happen to know that K is the following pattern. So you're given two arguments, and you only keep the first one. You get rid of the B. So that's going to make our substitution part pretty simple. So it's sort of AB.A. So second step, or 2A, 2B now, is our substitution. And let's scroll down a little bit. Or I can just zoom out. Let me know if it's unreadable. And the substitution is just going to be throwing away the B, which in this case leaves us with X. And then we're done. So basically our end condition is that and when, so we're going to have some loop in our program that's a while loop or something, and it says and when there are no more SKI, WB, Cs, any of these things. And so that basically means like we have all, in other words, all lowercase letters. And what this means is like we're left with X, but we're just basically going to reduce this like anytime we have X, Ys, and Zs or whatever. like having X here is the same thing as having A or B or C. But we'll sort of add that adjustment thing later. So hopefully that makes sense. We're going to do one more right before we get into the programming part. Masinchin, I probably pronounced that wrong, says, would SKS be the same as SKK? It seems for me that B argument can be whatever, since KC would always return C. I think you are correct. There's something that I, in my head, call K duplicates, which is exactly what you're talking about, is that whenever you have KX something, because we're going to throw this out, even if it's, B or it's paren C, W, because we're always throwing it out, it's the same thing. So they look different, but they're what I call K duplicates. Like, they are spelled differently, but because of the sort of discarding nature of K, they're the same thing. Connectity says, can't you write recursive statements? I know depending resolving order, it would terminate, but that's not really the no combinators condition. I don't understand that question. I mean, you can probably do something recursive, but I mean, this is going to be recursive. We're basically just going to we're going to basically build up a function called something like translate that is going to translate from this combinator spelling to this function abstraction. And actually, maybe I don't really know what this program is going to look like at the end of the day, but it might be recursive, might not be recursive. I'm just going to take a sip of my tea. But yeah, let me know if you have any more questions about this I translation. But let's do one that's a little bit more complicated. And oh yeah, we're going to be ignoring the Y combinator. I mean, this probably is not like a academically sound method that I'm using. This is just like my mental model for how this stuff works. The Y combinator is something that exists in combinatory logic, but I don't really consider it like it's something different compared to like SKIB, B1, WC, etc. But maybe in a future video we'll do some stuff with the Y combinator. But so let's do B now. So B is ABC dot AC BC. Yeah, we're gonna ignore the Y combinator for the purposes of this video. So we've got this to start, and what is our definition of B? It's this S paren KS n paren. So let's begin. Step one is to map. So we're gonna do A, B, and C. And C in this case doesn't exist, so we're going to call it X. Step two is to, I guess this was step one. Step two is to look up. Actually, sorry, what am I doing? This is the B combinator. The pattern that we were looking at is the S combinator. So that's look up. Then 2B is substitute. So in this case, KS is A, C is X, B is K, and then C is X again. Can I explain the bigger picture? AK asks. The bigger picture is that we're building up a translation function to translate from these combinator spellings in column 4 to the function abstractions so that we can basically generate different combinator spellings of these combinators, and then we're going to populate this column with simpler expressions than this. That's the goal of this video. And you can also go back and watch it at like 2x speed if you want. It might make more sense that way. So step 2b is substitute, and we never did step 2c before, but we remove parens. And in this case, whenever you have parentheses that start at the beginning, we can get rid of those. So delete this set, and that gives us 2c. And now we're going to repeat this process with k. So this time step 1, I'm going to stop typing out the map lookup sub remove paren. We are going to assign. So here we only need A and B, which are going to be K and X, or S and X. Actually, let's just keep doing it. It's be less confusing. K is discarding B, so it's just A, which is the look up the pattern. Then we do the substitution. Substitute, which is going to be basically S, KX, and then we get rid of this X. And we're going to skip 2C because we have nothing to... someone says, I have no idea what's happening. Hopefully, so I'm just walking through what I'm about to program. Hopefully when we have this basically translation function, we can look at any one of these combinator spellings and then see if it actually generates this. We're going to build up some unit tests, and we can create like a pretty printing function that basically spells out this whole process. Hopefully at that point, things will make sense, because I know this is kind of confusing and abstract, but hopefully by the end of this video, it should all make sense, because I did this one time, like I said, like a year ago or something like that, and didn't understand any of this until like the act of typing this out for myself like made me understand it. And I think I'm forgetting a few things from like when I did it a couple years ago, so we're going to run into those things again, and yeah, hopefully it'll be good. Anyways, so we do the substitution. We don't need to do a removal of the parentheses, so we go again. So we are going to go A for KX, B, C, and in this case, because we've got nothing there, we go YZ, and that's going to be our mapping step. Then our next step is to look up the pattern. We have S, so S is AC, BC, because we're looking it up from here, which is AC, BC. And that's step 2A is look up. Then 2B is substitute. So A is KX, which goes here. Then we have C, which is Z. Then we have B, which is Y. And then we have C, which is Z. So that's our substitution step. So once again, we've got our sort of A, B, and C mappings to parentheses KX paren, that's A, Y, which is B, and Z, which is C. We have our pattern, and then we just use this sort of matching of letters to other letters to get this spelling. We then go to 2C, which is to remove parens. And that's going to be the first one right here. So we're going to copy and paste this and get rid of the first set, which is going to be this. And then we repeat the whole process again. So in this case, we've got K, and we only need A and B for this. And I'm not going to type them out this time, but we know that the pattern is ABA. We discard B, and when we do that, we're going to end up with X, paren, Y, Z, because we've got this, and we're deleting the Z. And what do you know? X, paren, Y, Z, and paren is what we are hoping to get. So here, X is A, Y is B, and Z is C. So like what we call these arguments, A, B, and C, or X, Y, and Z, doesn't matter. They're just the name of arguments. They can be anything you want. And so even though technically this looks slightly different than what we have here, these two things are definitely the same thing. So Connected asks, is the reason for C++ a different one than prior knowledge? Absolutely not, no. This would probably be a lot easier to do in Python or something like that. I mean, if people really want it, we could do it in Python. Let me know in the chat if you want me to switch to some other language. And I mean, Python probably would be a lot easier, but it's going to be a lot slower at the end of the day, because we're going to basically create like a simulation of, we're going to create like thousands and thousands of these spellings and then translate them into their function abstraction. And so that's going to take a lot longer in Python. But if that's what the people want, how many people are watching? 32 people? Yeah, next question. So yeah, if a bunch of people in the chat want me to change the language, I can. I have no idea about combinatory logic, but it is my plans to study, so why not get an idea? Rubik's asks, is this a safe space? It should be. I mean, I'm looking at the chat, and if anyone gets out of line, I'll boot them. So definitely support everyone in terms of whatever their identity or however they express themselves. I'd rather stay with C++, keep C++, 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 one Rust, but we're doing C++. The people have spoken. All right, let's begin. Hopefully, maybe this made sense, maybe it didn't make sense, but we're gonna start programming, and we'll build the unit test first. We'll keep this all on screen. So what are we gonna need? Should we use format, or should we just use IOStream? Let's bring this back, and we'll switch to something local. Format core.h. Let's use format. So let's add our format library. And we want format print hello YouTube. And is this going to show us the execution? No. Execute the code. There we go. We've got the beginning of our program. So what's our first thing that we want to do? We want a function called, we're just going to call it translate. That's going to take a std string for now. Maybe we'll take a string view later. And actually, let's put some compiler options here. We're going to be doing with C++ 20. And for now, we'll just do no optimizations, but we'll add those later. And this is going to give us back a string as well. And let's just, I mean, we could add like a unit test framework here, but that's too much work. We'll do that in a follow-up video. I want to keep this less than 3 hours. A unit test. And this is going to take 2 strings, input, I mean, yeah, let's just do that. I mean, I guess technically we can use string views here. Why not? And should we make these have side effects? Rubik's asks, what's your #1 tip for someone who knows Haskell very well and wants to learn APL? Attend Appleseeds. There's a link in the description to a conference that's happening on March 22nd, half-day conference, completely free. There's going to be lots of great introductory talks. That's not a joke. I'm dead serious. And there's more talks online as well. And this is kind of, is it too small if I do it like this? A string view is basically a non-owning string. So, I mean, in the old days, you used to pass things like strings by const reference. But I think best practice now these days is you can just pass by string view if you're not going to modify anything, and then you're good to go. And what we want to do here is something super simple. So auto result equals translate of input. And then how do we want to do this? Format print. Actually, so we want to check that the results is equal to the expected, and then how do we do this? We kind of want correct and x, and then I guess we need to put those in I don't actually even know how to use print correctly. So we'll just do it the old school way of sort of input. I mean, we really should. Actually, let's just try this first. So what's our warning now? It doesn't return anything, so let's just return nothing for now. And could not convert. I mean, so that works now. So if we go unit test, and we have I, and we expect A, what happens? Right. Perfect. This is kind of irritating. So let's do that then. Input result expected. And actually, let's switch the result and the expected. All right, so now we've got our unofficial unit test. So now we can write a few of these. If we go S, this is going to be A, C, B, C, and all of these are going to fail right now, right? And so if we were to actually return something like A here, it's now going to tell us that our translate function is working correctly for the I combinator, but it's not working correctly for the B or the S combinator. And let's do it. Let's do a couple more because this is fun. This is fun. This is, oh yeah, and so we're gonna have to do some hack because we want to keep these to single letters. So H will be the B1 combinator because I want to keep this simple, and I'm gonna assume that every combinator is spelled with a single character. And so I don't want to mess around with B1 or anything like that. Or when it comes to, like, you know, phi, well, maybe we'll go get the phi character. I'm not sure if Unicode's going to mess this stuff up. But we might, in certain cases, just come up with a single letter that we're not going to use today for another combinator. But so in our case, H is the B1 combinator. What else should we add here? W? Should we do W? Let's do W. And we should also do C for sure. So W is a BB. C is a CB, I believe. Yeah, ABB, a CB. And let's do, yeah, one of the fancier ones. Let's do the phi combinator as well. Except what are we going to call? I mean, should we go get the, should we go see if this might break? Because C++ doesn't really use Unicode correctly. But We can try for now. We can try for now. I mean, it seems somewhat. All right, so we've got a bunch of unit tests now. Hopefully this, even the unit test part, we're not really doing anything yet. But let's go up, and we're going to actually try and get this to work now for the I combinator. That's the one we're going to focus on first. So comment all this stuff out. So the first thing we need to do, where are we at now? 45 minutes into the stream, and I'm already just starting to actually do the coding here. That's also, yeah, that's fine. We first need like a mapping. So let's, can I do this with a hash map? Unordered map. I mean, it doesn't really matter. It's less characters to use a map. And if I go auto dictionary equals stood map, like I don't even know if can you use a initializer list for this stuff? And then this is going to be a.a. And technically, you would need like a initializer list of initializer lists, right? I mean, the compiler says that's okay, so let's see if we can return dictionary of S. Is that going to give us back compilation failed? No match for, oh, because it's a string view. Well, let's make it a string view. Perfect. So we are now successfully looking up the function abstraction of our I, which is good. And now actually we did this kind of wrong, didn't we? Because we don't want to be passing I in. We want to be passing like the definition in. So really this is SKK. How should we do that? Should we change it? Let's change it. So this should be SKK. B should be SKS. Or SK that. What was B1? B1 is triple B. And so this is, actually wait, so I have this wrong. This should be B. And this should be B1. Which means that I need to switch these two. S is, what is S? S is just S. So I guess we're not switching, I guess we're not testing that one for now. What is W? W is CBMR. We'll get rid of 5 for the second and just look up C. So C is going to be a really good test. Can we, what's going on? If we can get C correct, we're going to be in really good shape. correspondence to phi for Greek is F, so you can name it like that. But now you can't define combinators by not SKI? I mean, we definitely can. So basically, we're just going to slowly add our function abstractions for each of our combinators here. And so as long as it's in our dictionary, we can define our spellings in terms of whatever's in here. So really what we're going to be doing here, SKK, we want the, does stood string have a front? Ooh, and that's actually interesting because we need to make this a car. All right, change of plans. And we want this. So now it's going to work, but we should basically add a line here that says if s.front, I was going to write Python not in dictionary, but of course we can't do that. This is C++ 20 though, so actually maybe we have the contains now. Let's try that. Dictionary contains. If not, I guess we have to do parentheses. Look at that. I'm basically coding in Python because it's more ergonomic. Then we can return the string that is basically will this work? Missing from dictionary. Actually, let's just do that for now. We'll make it make more sense. I hate the exclamation mark. Yeah, so perfect. Except now we want our message to actually print. So how do you, using namespace stood string literals, I believe is how it's spelled. And so now if I put an S there, I can just add the string, I think. Right, so now it's telling us that at the beginning of each one of these translations, it's trying to look up in the dictionary what combinator, what the combinator function abstraction is for each of the first ones, but S, B, and C are not there. So we need to go add them, which is pretty straightforward. So let's first add S, and then it's going to be abc.acbc. And hopefully that works. So now you can see that only these two messages missing from dictionary B. The other ones are at least able to find it. So let's just add the other ones while we're at it. B is ABC, except I'm not using double quotes, ABC, and then C is ABC, ACB. And as we start to use this more and add more tests, we're still missing, obviously, we only have 4 of the combinators here, but I look at the keyboard to type. Yeah, sometimes, you know. All right, now that we've got that, so step 1 is we need to do a mapping. And our mapping, you know, I kind of glazed over this, but the way we need to do it is basically we need to split on the value returned from our string. So autoconst, we're going to call this combinator equals s.front. Maybe we should give s a better name. Spelling. I mean, S wasn't that bad. And the next thing we want to do, we need a split function. Let's just write one. Auto split on. Can we use a string view? Let's just use a string. String s. I never remember. Let's go to which one of these do we want to use? Find first of. Find the first occurrence. Yeah, the keyboard's nice. I can't even remember what it is. It's like a Logitech something something RGB. I guess we can just use find. I mean, it doesn't really matter. So s.find, and then what is this going to give us? This is going to give us index, right? Yeah. I mean, this is where it would be really nice if we were using Python, because this stuff is trivial in Python, and now I got to go write my own split function. Is it mechanical? Yes, it's mechanical. I bought it a couple years ago, though, so I don't entirely remember the details. And then I think we just want to return I guess maybe we don't even, that's fine, we already wrote it. And then we want to return s dot subster 0i s dot subster I plus 1 to s dot size. I mean, I probably didn't get that right, but what can you do? So now auto left, right, const, split combinator, and let's see if this will be accurate. Left plus a space. And actually, let's just put a couple question marks there so we can definitely tell. Will this work? Yeah, someone mentioning I should run Compiler Explorer locally. That's true. Would be a little bit faster. What is combinator here? Const car. Right. Because we messed up the lookup. So this is auto const, and we're going to call this fun abstract is equal to dictionary combinator. And the fun abstract is actually the thing that we want to split, not our character. I'm definitely not running this locally. What am I coding? A bunch of combinatory logic stuff. What kind of programmer am I? I am a C++ developer at NVIDIA. And as you can see, we are correctly now splitting our function abstraction based on the period. And that's the first step. So then the next thing I think we want, and so actually let's call this right thing is our pattern. And the left thing, we'll call left for night. No, we'll call args. And I'll just print this out for now. So we're trying to map, and so basically we're going to map combinator rest equals spelling. Do they have a substring? I'm not sure if they have a substring method on string view. But basically we want this to the end. What's the error here? Did I spell it wrong? I did. Very nice. So the rest of it is basically what we need to do our matching on. And how are we going to do that? So in the case of I, if we scroll up to what we had here before, we've got our pattern. So we've basically done 2A now. We need to do 1, and then we need to do our substitution. So how are we going to do that? So in the case of I, SKK, we've got combinator is going to be equal to the character S. Rest is going to be equal to the string KK. Fun abstract is going to be equal to the string ABC. Actually, it's going to be just AA. And then we've split args to be A, and then pattern. That's actually not true, because it's supposed to be for S. So this will be A, C, BC. So args here will be ABC, and then the pattern will be ACBC. And so now we need to match ABC to KK. And that involves adding extras if necessary, meaning like the X, Y, and Z. My keyboard has arrow keys, yeah. It's a 105 key layout. So let's do this. This is anathema to the way that I program. But let's just do this with a for loop, and then we'll switch it into an algorithm in a sec. So int I equals 0, I less than the size of args. And let's create a sort of mapping called studMap, which is going to be a car to a string. And each time what we're going to do is we're going to go mapping of args I is equal to And I guess we need to tokenize. We need to tokenize our rest. Because in this case, we're fine, but in the future, we're going to have things that have parentheses. So what's the easiest way to do this? I guess we could get a function, or we can just do it inline. If, man, this is terrible code, but we'll clean this up. It doesn't have to be nice to begin with. Int j equals 0 if rest, and actually we need to start this at 1. If rest j does not equal a parentheses, we're good to go. So then we just call this rest j, except this needs to be a string. So subster j1 else, and then this is the case where we need to deal with a token that is like got some stuff in the middle of it. We're at the hour mark. It's all right. We're making slow progress. So I guess we should add parens here. Else, what we need to do is we basically need to, while paren count equals 1. Plus plus j while paren count is greater than 0. And actually, do we need to save j? Start equals j. And I guess maybe we can fold this into the loop. Plus plus j, and then we do if rest j equals left paren count plus plus. Why isn't it happy with that? In the else case, minus minus. And once we're done this loop, I think we do one more of these, and then we go mapping of args dot I, whoops, is equal to rest dot subster of start and j. Damn. Does that work? I mean, we don't know for now. But hopefully, if this is programmed correctly, we're now going to have this mapping. So we can move this into a function at some point. But we'll clean up the code in a bit. We're just trying to get this to work for now. So now we don't have our map. No, yeah, so this mapping is our map here. We've got our lookup pattern. So now we just need to substitute, and that shouldn't be that bad. So, And actually, so this is going to go through our number of args, right? So we don't want to... And actually, so yeah, this should be else if. The first case we have to check if j is greater than rest.size. What should... I mean, we need to start lower than x. Should we just start at like... What letter should we start at? Does it hurt if we start at A? I think we can just start at A. Car letter equals A, and mapping dot args I is equal to letter, and then can you do a pre-increment on our letter or post-increment on our letter? Because it's just an integer at the end of the day, right? Correct. So that should deal with the cases. So now this is going to be great. Now we're going to basically just do, so this is step 1, create mapping. Somewhere in here is step 2A, which is look up pattern. Now we're going to do 2B. So step 2B, substitute, which is we're going to require our mapping and the pattern. So in this case, our pattern, yeah, is this. So we're just going to loop through. So yeah, let's, once again, we're going to do something that looping plus pattern. I hate writing code like this, but we will refactor this later. String, what do we call this? We'll call it sub. And we're going to initialize this to be empty. And we're going to go for int I. Actually, do we need the index this time? I don't even think we need the index. So let's just go for const character in our pattern. We are going to go sub plus equal to mapping of that character. And some cases this will be a 1-character string. Other cases it'll be like the tokenized thing. And now, for the first moment of mini truth, if we return this sub, in our case, we will expect, I mean, what was it here, right? So our first translation for SKK, I mean, in our example, this X is going to be A, so we should end up with KA parentheses KA. And actually, there's a small bug in this that says that is wrong. So if C equals this or C equals this, then we just want to sub C else. So actually, sub plus equals, I don't know if I'm going to like this or not. I mean, do we even need parentheses around this? Is that going to work? Oh, except a ternary, yeah, never mind. It's not going to work because the mapping is returning a string, and C is going to be a character. So just leave it like it was. And so now, yeah, let's return sub and see what we get. Wah, wah, wah. So that did not work. I mean, it's close, right? We have, this is 1, 2, 3, 4, 5, 6 characters, and 2 of them are wrong. So 67% is not bad. So my guess off the top of my head is that our index starting at 0 somewhere is wrong, right? Because we want to start from here. So actually, let's just print our mapping first. For auto key value in mapping, format print and let's also do a, so yeah, this is getting K every single time. Why is that? Let me know if you see the bug. Oh, the bug is that we don't increment J anywhere. I mean, we did improve, or did we improve? So the first time through, actually, yeah, if this doesn't equal this, J++. The second time through, why does it get nothing here? Dun, dun, dun. So we're going to print out J, rest J, yeah, what's going on here? Let's change this rest J to just rest. Oh, right. So I'm starting this index at 1, but I've already done that by splitting out rest. So this should actually start at 0. Whoops. I mean, so now we're back to KK, but now we've lost the A. So we get K, actually let's add this back. We get 0K, 1K, 2. Why does J... There we go, folks. So this is definitely the first step. And let's just focus on I. We'll ignore the other unit tests for now. So let's comment out some of this stuff while we don't need to debug. And so the next step is basically, so that was step 2b. We'll skip step 2c. Actually, we'll just put a little test in here. If sub dot front equals this, then we return need to implement step 2c, removing the parens. But we'll do that later because we're just getting I to work now. In the meantime, we're done basically 1, 2a, and 2b, which means we can now recursively call, actually, yeah. I mean, how do we check if it's lower? If stood all of ranges sub. I don't actually know if that works. Does that work? Return sub. All of, I don't have the algorithm header. Now we've got our base conditions, so otherwise we're going to return translate of sub. Nice. And let's do a format print. so we can just see our progress each time this gets called recursively. And we need that. So it would be pretty magical if all we needed to do was to add k here. Wow, look at that, folks. We have our first unit test passing. And currently, at the moment, the only reason the other unit tests are failing is because we need to implement step 2c. So let us do that. First of all, let's change this. Yeah, woohoo! I should be more excited. My lack of excitement is because of how god-awful this code is, but we'll clean it up. We'll clean it up. I mean, first things first. We're an hour and a half in. I said this was going to be 2 or 3 hours. The fact that we have the I Combinator working is pretty awesome. So you can see here that for the this is the I Combinator. This is the B Combinator. So at this step, we've got parentheses. So we need to get rid of these. So the problem is that are we going to run into an issue if these are nested? And the answer is yes. So basically, we need to find the first set of matching parentheses, in this case at index 0 and index 3, delete those, and then recursively call remove parens on our string at that point. So let's just make a standalone function called auto remove parens. This takes std string, and it's going to return us back a std string. And technically, we could like assert. Actually, I mean, we wouldn't need to, but like based on the way that my code currently works, we're checking if the first one is a paren, but whatever. But let's just we'll put a fake assert in here. Maybe we'll do it later. Assert first char is paren. So we know we're going to be removing a 0. And is there a string method for delete? Actually, I guess we can just look at it here. Erase. Let's look at erase. Why not go to that? For real? Oh, I have something messed up. I might have just opened like 16 different. I did. You can take an iterator. Is that really the one we want? Erase. It takes a position. Okay. So I mean, let's just that should get rid of the first one. And we honestly want like the exact same code that we have here. Can we take this out? We need J. That's all we need, right? So, I mean, here's how, this is like, there's been a bunch of talks given about how to refactor things out. Auto, we'll call it just I. Well, we already have an I. Let's call it auto X equals and actually we can just call it J. We can just assign it to J, and then we can go J. How does this really work? We're passing it in as a value. J equals J. And I guess we also need rest. And is this upset because it's mutable, not mutable? I mean, I'm confident we can put this into a function. All that it needs is rest in J, so find end. This is why I don't love working with C++, bad documentation sites, too old comparing to with Rust docs. I mean, CPP reference is just fine. I just couldn't click on a link correctly. And then we are returning J, which in this case, we can actually just do this and return J plus 1. I mean, actually, are we going to want to return J plus 1? So find then what is it upset about? No matching function call for int reference. Well, I'm not passing it as a reference, I'm passing it as a value. No return statement on line 72. Well, that's a different thing. We'll deal with that in a sec. No matching function call for int basic string. Start was not declared? True. We're still upset. Because why? What is rest? Rest is a string. I mean, does this need to be const? Is that what it's wanting about? No conversion from argument 2 from const stood basic string view car to stood string. Oh, it's a string view. That's why. That's why. All right, that's fine. Now, because we have this function, I don't have to repeat that code, and I can just use it here again. Find end 0 s auto I. And we can go s.begin plus I. I don't actually know if that'll delete the right one. And for the moment, let's just return s. And now we don't need to return anything here. While sub equals remove parens sub, and I assume this is going to break. Yeah, it definitely broke. So what are we returning? Format print remove paren. So this, and actually let's print it out before too. So we successfully get rid of the first one, but for some reason find end is not working here. Print count is equal to 1. We're adding to J. So I think we want to just return J, and then where we are using it down here, we call that J plus 1. Perfect. So we end up with, for the B combinator, KSA, is that what we want? KSX, KX, fantastic. Actually, let's move. Hello to John, who just joined. I mean, this is going to be very confusing for you. So we get down to KSAK. I mean, this looks right? Oh. So, also, we kind of skipped by the fact that this worked, which is pretty nice. So we want either is lower or is punctual. Is there a function for that? CPP reference like is punctuation. No, that's not what I wanted. Is punct. That's what I want. Yeah. Problem is now is what we want is we want a phi combinator, but we don't have access to a phi combinator. Because really we want some way that's just is punct or this. That's what we want. However, we're not going to be able to do that, so we're going to have to write a lambda. Which is not the end of the world. Wrong brace. Right brace, missing, right parentheses, missing the. So actually we messed up somewhere here. KSA, that's correct. The next one we expect is oh, right. So we can see what's happened here, right? Is that we've gotten to the second step of translating the B combinator, and it did it correctly. It did KSA, but we discarded the parentheses KA because K only looks at A and B, and right now in our code, we do that loop based on the length of args. Therefore, in the case where we still have stuff left, we just need to tack that on, which is pretty simple. So if we get to the end of this loop, and so if we get to the end of this, and if j is less than rest.size, is it as simple as... Actually, no. No. Actually, well... How do we do this? Stood string need to add equals and if it's this, then it's going to be rest.substr j to rest.size. Otherwise, it's just going to be an empty string. And then it doesn't like this because we have an extra parentheses right there. And then once we are done building up sub, what? Oh, this is a string view too. I mean, can I just do that? Unable. String view literals? Yeah, this is all being done in what is it whining about? So it doesn't like that. I mean, do we use J again here? We do. Oh, right, because that's the problem. Should have just used auto, folks. Yeah, and then now that we have this, we can add to the end of sub, need to add. Fingers crossed. Why not? Why not what? All right, we're getting a lot closer. So now you can see previously we had S and we were throwing away this parentheses KA. That's not the case anymore. Why not using auto? No, I was saying like I was using this substring on this string view was returning a string view. And I thought the issue initially was that I was using a string literal suffix instead of a string view literal suffix. But the real problem was that I was using stood string. So the alternative, if I didn't want to use auto, was to explicitly say string view instead of string. But if I just had not have been using stood string and just used auto, I wouldn't have had that compilation error. It would have figured out based on what I was trying to return that it's a string view that I wanted, not a string. So what is the problem here, though? So we have SKA. And that's exactly what we have here. Then we get to KXY. Ooh, that's a problem. I know what it is. So yeah, folks probably can't see this. So we've successfully now, I mean, we've got our I combinator working. We've gotten past the first step of the B combinator, second step of the B combinator, but now we're getting mixed up on the third step of the B combinator, and that's because I've hard-coded this character letter. So whenever we have to extend past the length of our pattern, I say start with A. But that doesn't work if we already have an A in it. So really, our start letter should be 1 plus whatever the current existing lowercase letter is. So we can just do something really quick here and immediately invoke lambda. And let's go get that code that we have from down here. If actually, what do we want? We want the maximum lowercase letter. What is the nicest way to do that? We could do a fold. Should we just do that? Should we just do that? And we're going through rest. We're initializing this to be the character A, and then I guess we need to add numeric. If is lower, and What's interesting is actually, I mean, we'll do it this way, but depending on the ASCII values of this, uppercase letters start at like 50, right? Or 49, and lowercase are higher. And if parentheses are also lower, then we could just not actually check if it's lower. And this now needs to be and so we actually want to add, yeah, actually now we do got to go to an ASCII table. So yeah, parens are 28 and 9, uppercase, lowercase. So backtick is 60. Don't do this at home. But we actually just want the if only we had a passable max function in C++. Look at that. So what I'm doing basically here is I'm doing a reduction over our, combinator spelling at this point, initializing it to be 1 less than lowercase a, and then adding 1 to it. So if we don't find any lowercase letters, it'll end up being a. Otherwise, it'll end up being the next smallest lowercase letter. And we now have both the B combinator and the I combinator working. Magic. So the question is, why aren't the other ones working? Can't I use stood range as max? Well, let's find out. Oh, I see what you mean. Maybe. I mean, we need to be able to initialize it to something, though. Are you saying, though, can we potentially pass in stood range as max here? I definitely don't think so. But if you're asking, can we use it instead of stood accumulate? We can't. I mean, we could write some slightly different code. But yeah, we'll leave it like this for now. All right, so and actually, I want to switch this unit test to also take in so that we can print it more nicely. Car, combinator. And then we're going to go this is I, this is B, don't need the comments anymore, and this is H. This is W, this is C. is there a comma? We don't really want a comma. So I's working, B's working, B1 is not. So we go B, 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 and we end up with M. What the hell is M? Oh, look at that. M is actually for the next one. But we actually, this is correct. We just have an extra set of parentheses here. So we can just modify our code and check if there are successive left parentheses in a row. Yeah. So we can just do another loop here that says while stood adjacent find of return L equals this and R equals this. This one assumes that you always start from the beginning, though. So we need to modify this. To either take an iterator, or no, remove parens. Either take an iterator or take an index. So if we go back to remove parens, okay, that change seemed to work. All right, thanks for watching. Enjoy your sleep. You can catch the rest of it. It'll be on YouTube afterwards. Shouldn't I be able to recurse into parens and add the result? I don't know what that means. So I mean, there's got to be a nicer way to do this, but auto it equals actually, yeah, let's do that. Is the treat text inside parens same as the whole parse? Yeah, that's true. We could do that. But we're doing this. Auto double left paren equals return Is that accurate? We need a parentheses here. One less parentheses. A semicolon. And it DLP sub while it does not equal sub dot end. Now we call sub equal remove parens sub and stood distance from sub begin to it, and then we go it equals DLP sub, and I mean that might work. Oh, don't do that. I mean, that's sad. I mean, what if we just do it once? My guess is that we're in some kind of infinite loop here. No. My remove parens function. Stood distance. Oh, it needs to be I mean, actually, it doesn't really matter. I think it does matter, though. It's that we're returning an iterator to the first left parentheses when we should be returning it to the second one. Still doesn't like that though. And so it's going to erase the inner one. Then it's going to find the end. I mean, if we delete this, hopefully it should just go back to the issue that we had before. Whoa. Why are we getting crazy numbers like that? Oh, maybe because yeah. Well, now it doesn't like. All right, let's just go back to the reference. And let's go back. So yeah, this should be plus 1. And that's going to give me 2a. So yeah, then it should erase that. So it's obviously clearly somewhere in here. What if we don't assign it back to sub? Oh wait, we're not if yeah, it does not equal sub dot end. Still not happy. Man, so definitely something totally is. So we get to this point, 0, 1, 2. We enter remove parens. We're going to erase sBegin plus 2, which is going to give us back this. Start is still 2, so we're going to go up to find n paren count is 1 with j equal to 2. We're going to go to C, then we're going to go to there, paren count should then go back to 0. And then it'll be pointing at 0, 1, 2, 3, 4. And then it should be the start might not need to be there. I mean, now it's working at least. So add back our setting of sub. Woo! Small bug fixed. And I mean, technically, should we put back this recursive thing? Or not recursive, but just iterates on it. I mean, we're going to ignore, or should we, let's see what happens if we put the mockingbird in here. What is the mockingbird? I mean, I don't even have M listed here. Goes to show you how much I don't really like the mockingbird. I have a feeling this is not going to make W work though. I need R too. What is R? The robin? What do you think? Think that's gonna work? I don't. Look at that. Did that work? No, it did not. So now it's saying ABB missing from dictionary. So what's well, yeah, it's clearly messing up here. Let's focus on C though. So yeah, clearly something gets messed up here because we end up with BBBS, but it should be, if we work through this, this becomes A, this becomes B, and then there should be a C at the end. So yeah, let's print out the mapping. So let's comment this out for a sec. Just look at C and then go back to printing out We're getting close. We're almost done here. 2 hours and 15 minutes. 45 minutes is more than enough time to get this working. So yeah, this is our little mapping that we're printing out here. So my guess is this is where it's broken. Yes, clearly is. So why? We got A right, we got B right, but C should have been assigned to A. So why is that not working? This is where we get the tokens. Do I need an extra plus plus J over here? And that's just a random guess. Nope, definitely not. That was not correct. So let's walk through this. We've got BBS KKK. So it's going to go to each of these first. And then on the final one, J should be one past the length. So let's just print J at the top of this loop. So J is 0, 5, and 9. So if it's 9, that's going to get us 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Does it not go in here? Hello, I need a letter. It doesn't. Why does it not? Why does it not? Zero, 1, 2, 3, 4, 5. Why is the rest? Oh, no way. The bug is that I typed an extra space here. Okay, that's very sad. I mean, it'll be nice if it actually ends up working at the end of the day. Yes, Rubik's, it is very dumb. But that is classic programming stuff. So let's delete all that stuff. Go back to commenting out our mapping. Actually, I guess we can leave the mapping through this and just walk through for a sec. So this looks correct. And then we end up with BBS A KKA. That's correct. Then it's going to be B, which is going to have ABC, which is going to parenthesize the SA. Everything else is good. That's correct. Then A is going to be SA, KKA. We're going to add a B. And then we're going to parenthesize the KKAB, which is correct. Then we're going to assign A, B, C. That's going to give us A. And C, that's all correct. And we're actually super close. I guess, yeah, the only problem here is that we are always processing the first letter. And here we need to be doing this, which K is going to get rid of, the first K is going to get rid of an A. The second K is going to get rid of the B. Actually, no, wait. The first K, this looks right. We don't actually have to mentally work through this. The problem is that, I mean, maybe Paul was correct, is that we should have just been processing these parens recursively. Right now, what I'm trying to think is if we split and then call this translate on each sub thing, would that work? I mean, probably that would be the better thing to do. But I feel like that's going to take more rework than I want to do. The easier thing, in my opinion, is once we get down to sub. Paul says, I've never been right in my life. Let's not start now. I mean, I think you're probably correct. But there's an easier thing we can do. And that is that if the first letter is not lower, not is lower, might not be the nicest way to spell that, then instead what we can do here is how do we do that? How do we do a sub dot I want the index of the first non-lowercase letter or punctuation. I mean, is there going to be a case where I think actually it's a sub find. I mean, if this doesn't work, we can fix it, right? Auto I. And then we can return sub dot substring 0 to I plus translate of sub dot substring I to sub dot size. It's a hack, but it is lower. Actually, should we translate the whole thing? Is that what it's asking for? Man, this is getting so messy. We'll clean it up later. Okay, we're just hacking here, so we should try and think about this correctly. So first, let's see, you know, what does this come to ultimately? What is going on here? Translate. I mean, we might not actually need to remove half. That's true. That's true. I mean, it might work for this case, but the more that we're doing this, the more I'm thinking we should have just taken Paul's advice. Man, why? I feel like I'm writing Lisp here. Oh, right. Remove parens, though, is... oh, yeah. I mean, it works. My guess is that it's not comprehensive. I mean, is it working though? Why is it whining about that? I mean, let's go back. And if we uncomment our unit tests, actually let's not do S for the moment. I mean, should we risk doing phi? See if phi works. Oh, it doesn't even have one. All right, let's do another one. D is BB. And what is D? D is this D? Yeah. I mean, D works. Does W work yet? Actually, let's go comment out this line. I mean, we need that line back actually now, but so why? I mean, first I want to get rid of this thing. So we get down to this. I thought the remove parens though would get rid of that. So if the first one's lower, it finds the first one. Oh, that's why. If I delete this line, it's coming from that call where we didn't call remove parens. Yeah. And so what's happening here? BMR, MRA, RARA. I mean, I think for now we should just get rid of this test because honestly, I've never intended to put M and R. Like, I don't want the Mockingbird, if I'm being completely honest, in my little dictionary that we're building from. And I don't want R in there either. It's not a fundamental combinator. So it's compiling now. We get rid of this line. And all of these are working now. Let's just go add a few more. I mean, the fact that we got C right, C is the most complicated one. Let's do B2, which we'll call H. I mean, if we're going to call this H, what do we call the other one? I, J. J will be the B2. Put this in parentheses. And And it just turns the binary function into a ternary function. And it should be Z, not, or J, what do we call it? I mean, the fact that we're just using those to print, it doesn't even matter. I mean, that one works as well. So it seems like hip hip hooray. We've got it working. I mean, what should we do next? Should we do the thing that I said we built out to do? I mean, or should we split that into another video? Because basically, I mean, let's do it for a few. So what's the idea here? If we create a string, auto const source equals stood. Actually, we just do the string literal ones, and we do this with, you know, b ski cc sk sskk ii cc. I mean, there's fancier ways to do this. And then we need a mask. And then we're going to need a hash map. Or just a regular map's fine. And then we go previous permutation. How do we do this? Because it's sorted, I guess. Wow. And first, to make sure I've got this right, int I equals 0 plus plus I yeah, this can't be const, obviously. Right. And so now the idea is that, I mean, how do I build up this string? I mean, let's just use a for loop for I equals. Int I equals 0. If mask dot I equals 1 s plus equals source of I, and then we go, oh, this is actually supposed to be a stood vector of strings. And then we go, what are we doing? We're going translate S, and we want to go translations of S pushback of that. And there's no I here. So then we go for auto key, what do we call it? I don't know, key value. Will that work? I think I'm just missing. Doesn't know how to print a vector. Right. I did this wrong, though. We don't want to push the trans. We want the original, like that. And now this is where things get exciting. So once it updates, we now have generated a list of spellings. I mean, right now it's only based on 2 of each of the combinators that are in our dictionary. But if we go and look for some of these, so these are all however many bajillion different ways to spell. Actually, so let's do it like this. To spell the I combinator. So yeah, we generated 23 different ways to spell the I combinator, 69 different ways to spell the C combinator, which is known as swap. We don't have like the S combinator or anything like that. I mean, I think the W is pretty important. So what happens if we come over here and add W, and we add AB.ABB, and then in our source, we add WW, and we add 00. And like the next stage of this project is to basically go and create a searching function that, oh, why is it upset? Is it just like a timeout? What if I get rid of the C's? No, it just does not like the W's for some reason. I mean, well, we'll figure out how to add W's in the future. It's unfortunate that didn't work. But this is basically the point, is that, I mean, we still have a little bit of work to do to have a more sophisticated way of building up spellings of these things so that we can generate spellings. But yeah, what happens if we... And the idea is like, you know, you'd prefer shorter spellings of these things, right? So the B combinator currently is spelt using SKSK. But, I mean, yeah. I guess, do all of these involve B? Yeah. I guess we should make a rule that you can't spell something in terms of itself. It's kind of cheating. And so like here also is the S combinator. Unfortunately, oh yeah, look at that. Why do we end up with... Oh, because these are all duplicates. So actually, let's update that. Good point. Make this a set, and make this a insert. Much nicer. So yeah, we used to have what, 10 of those? But now we've only got a couple. So obviously, like, most of these are uninteresting, right? They don't correspond to combinators that are in that table. But ideally, we come up with a more sophisticated way of building up these spellings, inserting parentheses into the spellings, and then we might end up with a... And we got to do some filtering, right? Because we're using S here. Like, this is an uninteresting spelling because it's basically composing identity with S using the B combinator, which is just like a fancy way of just spelling S. So you don't want to have a circular dependency by defining a combinator in terms of itself. So you have to build in some knowledge that, like, we know that this is S, so ignore anything that has that in it. But yeah, maybe we'll leave that for part 2. For the closing out this video, let's just go put this all in a repo. So let's delete this, delete this, delete this, delete this, delete this, and call this Combinatory Logic, CPP, code from live stream of public make this MIT, don't add a readme, and bxi equals x. Yeah, that's correct. Did the program find I made from II? No, because currently we're only testing combinators of length 3. So if we change this to that, though, yeah, it does. So we want to open this. And we want to touch main.cpp. And actually, let's put this stuff in like touch. And we'll do a thing where we refactor this in the future. And we can delete all this stuff for now. Yeah, we'll want to keep that potentially. We can add a readme in a sec. To do, make this more sophisticated. I mean, it just auto-formatted all my code. I hate that, but whatever. I gotta go get. How should I do that? Let's go to mix. Get my Clang format from there. There we go. That's what I wanted. I don't know why my line length is so long, but it'll do. And now I need to I mean, where's the best place to get a CMake file from? I mean, actually, maybe the best place to get it is actually just where we were. This one's way too complicated, though. But we can delete the stuff we don't need. We definitely don't need that. We don't need any of the test stuff yet. So just comment that all out. Don't need that. Don't need that for the moment. Just call this CL CPP. We don't need any of those. Don't need that. And all we want is format. So let's delete everything else. I don't think we want that either. Huh? Why? Why is it not happy about that? I mean, oh, whoops. Copying and pasting can be a hazardous. Look at that. All right. So that should basically be it. If we go here, you should now be able to go build this yourself. Where's the URL for this? Am I able to drop this in the chat if folks want to go play around with this for themselves? I'll definitely do a part 2 of this live stream where we clean this up, because this is, I mean, I hacked most of this together. It's pretty awful, pretty ashamed of this code. But, and then we'll clean it up and we will make this more sophisticated, work out any bugs there are. And then, like I said, the ultimate goal of this is to come back here, especially for the Phoenix and for Psi, and to fill in this column basically. Like, there's got to be a simpler version. And obviously, like, there's a hierarchy, right? Like, there's no spelling any of these combinators in terms of W. But I have, like, no qualms with spelling something in terms of W. And if that makes it simpler, you know, there's a graph right now where basically everything, you know, the first few are spelled out of S, K, and I. And then later on, you're allowed to use C, B, and M. But I think we should create whatever graph we want and fill this column in a way that makes the most sense to me or to us. Anyways, that's it for the stream. Hopefully this wasn't too confusing. And if you're watching this not live, feel free to leave any questions in the comment section down below, and I'll do my best to monitor them and to answer them as time goes on. And yeah, I'm going to try to not wait too long to do part 2 of this stream where we do the refactor and work on things locally now that we have them running. All right, thanks for tuning in. Enjoy the rest of your morning, day, evening, depending on where you are in the world, and we'll see you guys in the next stream. Cheers.